Good morning, students. We will start with electrostatics chapter 10. What does electrostatics deal with? Electrostatic deals with static charges, uh, unlike current electricity, which deals with moving charges. So, uh, now these static charges will have forces between them. So we study the forces between these static charges. And of course, wherever there is a force, there will be an effect of a force. So those effects of those forces are in the form of electric fields and electric potential. So just skipping the part that atoms are electrically neutral, we have studied this in lower standards, so not repeating all that. The number of protons are equal to number of electrons and neutrons are neutral, etc., etc. I'll just quickly move to how to charge, or let's say concept of charging by conduction. Charging by conduction. So we have dissimilar substances. Just take two dissimilar substances like fur and comb, fur and amber, and comb and dry hair. Let's say comb and dry hair. Here, they are dissimilar in the sense they are electrically dissimilar substances, because eventually each one is going to get an opposite charge. ठीक है, and we rub those two together, or rub these two items together. Uh, uh, Together, if you have very thick hair, you might have that experience where you have to move the comb in the hair very rapidly, so it develops a charge. uh, the electrons will get transferred to the substance which is making them charged, so here electrons will get transferred. And cause a charging, so the substance which receives the electrons will get negatively charged, receives electrons, and obviously the substance which is which gives those electrons, donates those electrons, it becomes positively charged. Okay. uh, this is charging by conduction. uh, Conduction, and it happens as charges are transferred from one body to another. Charges are transferred from one body to another. There is another method of charging, and that is known as charging by induction. Now, induction does not involve any physical contact, unlike conduction. so it does not involve any physical contact. And the body has to be just close to each other. Okay, so what do we do in that? We have an uncharged conductor. Is brought close to a charged body. Okay. Now the nearer side of the conductor, uncharged conductor, develops opposite charge, so that on the charged body and on the far side of the conductor, it will develop a charge similar to that of the charged body. So this is known as induction. Pictorially, I'll just try to yeah. So I have got, pardon my drawing, uh, and I have got a charged rod here. Okay. So a negative charge is developed, and on the far side of the conductor, it will develop a positive charge. So this is charged. This was previously uncharged, but now it has got induced charge. Induced charge. Obviously, observe that there is no physical contact. When I say charged, it is previously charged, and whenever since there is no marking here, it means there is an uncharged body. Okay, so this is charging by induction. Uh, Charging by induction happens because the electrons in the conductor are free. In the conductor are free. Uh, so as soon as this charged body comes, the electrons will tend to move towards the edge, so that they will try to discharge the body. Okay, so there will be a definite movement of electrons, and due to this force exerted by the positive charge, inductive force, they will some of them will even rise up to the surface, which is indicated by this negative point. So electrons in the conductor are free, and uh, they will move in presence of a they will move in presence of a charged body. Okay, now a charged body is going to attract or repel electrons in a conductor depending on its own charge. So in this case, I have taken a positive body, so electrons will get attracted. So if this was a negatively charged body, the electrons would have got repelled, and we would have had a positive charge. Okay, here uh, uh, in a conductor. Positive and negative charges would be redistributed. And they tend to accumulate at the ends of the conductor. and which is near and away from the charge conductor. Okay, as you can see here, a charged redistribution is taking place, and electrons are gathering at the near end and far end from the culprit conductor, this charged guy who is causing induction problems. In induction, there is no transfer of charges. Unlike conduction, where there is actual transfer of charges. So transfer of charges. So when the charge body is moved away, the charges in the conductor are free again. Okay. Another concept which we have to study is additive nature of charges. Of charges. This is very important. This is so obvious. So students generally tend to say, "Ki, sir, this is obviously true," but I like to always mention this. Ki electric charge like mass is additive in nature. In nature. This is a very obvious point, but I like to, as I told you, I like to mention this. Okay, and the total electric charge is the algebraic sum of the charges. Okay, uh, distributed on different parts of the object. Okay, of course, needless to say, since it is the algebraic sum, a proper sign of charges have to be taken into account. Okay, you can't just so if two bodies have equal and opposite charges, will neutralize each other. Okay, this is obviously also the case of atoms. Okay, atoms are electrically neutral because the positively charged nucleus has got exact amount of positive charge as the number of electrons which are rotating outside the nucleus. So neutral. So it's just like a concept which I had to mention. Not much of a problem here.